Somewhere in the constellation 10.4 billion light-years of travel time from where you are sitting right now, there is something so large, so violent, and so incomprehensible that the very words we use to describe it feel inadequate. It is not a star. It is not a galaxy. It is a black hole. The largest one we have ever found. Its name is TON 618. And before we can understand what it is, we need to understand what it came from. Here is a number to hold in your mind. Our entire Milky Way galaxy contains approximately 64 billion solar masses of stars. 64 billion stars worth of mass, scattered across 100,000 light-years of space. TON 618 is a single object, a single black hole, and its mass is 66 billion times the mass of our Sun. In other words, TON 618 is heavier than every single star in our galaxy combined. Not slightly heavier, not twice as heavy. TON 618 outweighs our entire galaxy of stars, and it fits within a space 30 to 40 times the diameter of our solar system. But to understand how something like this exists, we first need to understand that how black holes are born. We need to understand how stars die.
A star is a war. On one side, gravity, pulling inward, crushing everything towards the center. On the other side, nuclear fusion, pushing outward, burning hydrogen into helium, releasing energy that holds the star open. For millions of years, the two forces have balanced. Then something changes. The star runs out of hydrogen. It begins fusing helium, then carbon, then oxygen. Each fuel source burns faster and faster until, at the very end, the core begins fusing iron. Iron is the end of the road. Fusing iron does not release energy, it absorbs it. The outward pressure drops. Gravity wins. In less than a second, the core collapses. A mass equal to our Sun, compressed to the size of a city. The outer layers of the star crash inward at a quarter of the speed of light, then bounce outward in one of the most violent explosions in the universe, a supernova. Sometimes, when a star dies, gravity does not finish the job. What is left behind is a neutron star. The mass of our Sun crushed into a sphere 20 kilometers across, smaller than a city, denser than anything that has ever existed and survived to tell us about it. These objects spin. Some of them spin 700 times per second. And as they spin, they scream. Beams of radiation lashing out from their poles, sweeping across the cosmos like a lighthouse built from a dying star. We call them pulsar. Heartbeats from the edge of death. But a pulsar is what you get when gravity runs out of courage. Ours did not. At the center of our own galaxy, 26,000 light-years from where you are sitting, there is a black hole. 4.3 million solar masses, crammed into a space smaller than Mercury's orbit. In 2022, we photographed it. A glowing ring of gas spiraling into darkness, the shadow of the event horizon itself. And in 2026, we discovered something worse. A gas cloud near the galactic center is reflecting an ancient X-ray blast, still arriving, still echoing. Our black hole erupted just hundreds of years ago, shining 10,000 times brighter in X-rays than it does today. It is not sleeping, it is resting. And yet, Sagittarius A star, 4.3 million solar masses, is nothing. A dust grain, a footnote, compared to what is waiting 10.4 billion light-years away.
In 1957, two astronomers in Mexico photographed a faint violet smudge on a glass photographic plate. They cataloged it, entry 618. They had no idea what they had found. It was not a star. It was a black hole, feeding. Gas spiraling into it at millions of degrees, screaming with the light of 140 trillion suns. The galaxy surrounding it, completely invisible, drowned out by the light of its own black hole. Its event horizon, 1,300 times the distance from Earth to the Sun, more than 60 times the distance from the Sun to Pluto. Place it at the center of our solar system. Mercury, gone. Venus, gone. Earth, gone. Mars, Jupiter, Saturn, Uranus, Neptune, all of it, gone. And a beam of light, trying to cross its shadow, would take weeks. How does something this large exist? We do not fully know. The universe was only 3 billion years old when Ton 618 was already this size, a fifth of its current age. It should not have had enough time. Perhaps it consumed matter at rates we cannot model. Perhaps it formed not from a dying star, but from the direct collapse of primordial gas in the first chaos of the universe, bypassing stars entirely, born already monstrous. And what is Ton 618 now? We cannot know. The light we see left 10.4 billion years ago. Whatever it has become, we will not find out for billions of years. And Ton 618 is not even the largest. There is Phoenix A, estimated at 100 billion solar masses. The universe has no ceiling. None we have found. Black holes seem like endings. They are not. The same explosion that builds a black hole scatters the ingredients of everything else. Carbon, oxygen, iron. The iron in your blood, forged in the core of a dying star, scattered by the same force that, somewhere else, became a black hole. The light from Ton 618 has been traveling for 10.4 billion years. It left before our sun was born, before Earth, before the first ocean, before the first living thing. And it arrived here, at your moment, so that you could look up and know that somewhere in the dark, something 66 billion times the mass of our sun exists.